Good morning, folks. Looks like the party has started without me. How's everyone doing? Hopefully I'm live. It should be live. Good morning, good morning. Good morning, MT, Franco, iTestings. Who else is here? You guys have been chatting like crazy. Oh, MT has a 7-hour drive. Gotcha. Oh, and Gerald's here. Morning, Gerald. I'm almost done my second coffee. And that's because I've been coding this morning. So day 6 of my Learning to Code challenge. Journey, whatever you want to call it. So I posted that up on socials as well. How's it going, JB? So I am almost done. If you want to pull up my my Blue Sky post, I am almost completely done HTML. I probably could have pushed and finished HTML, but it's not a big deal. I'll finish it. I'll finish it in tomorrow's session. So yeah, look at everything here. It's Mrs. Test, Johnny. Get the demographics right. You had some smørrebrød. I actually don't know how to pronounce that. So today we are probably going to be taking a look at these temperature sensors. I kind of want to do a comparison video. So here's my problem though. I don't have enough displays to make a video with all 4 of these on the same micro or on different micros. Good morning, Lock Watcher. So as much as I would like to do all of these on the same, it's just not practical. So we need to define a set of test conditions for them. It's temperature and humidity for all of them. So I kind of have somewhere, I have a temperature chamber that I built with foam board and a whatchamacallit, a thermal thing. I don't know where that went. Did I destroy it? I built a foam board box to do temperature testing stuff, but I don't see it. It's pretty massive, so I should be able to see it. So maybe I did destroy it. A Lock Watcher and Brian Locks, yeah. You have 15 OLED. So that's the thing. I can order a whole bunch of OLEDs, but the issue then becomes that it doesn't matter if I have 15 OLEDs. They're not big enough. They're not big enough to put all the data on one. I could do with ESP32 though. I could have all of them on the same display. But I don't know if the SPI will... I don't know. What do you guys think? Should I try with the ESP32 display, or should I put a Should I use a Raspberry Pi in a screen? Or should I just make individual code for each individual one and then run it? Because they're really for environmental. The thing is also, the point of these. Oh wait, I had another idea, but hang on to that. The point of these would be probably, should probably turn on my studio lights, right? It would probably to use them on these things. Combine the code, it would be good. So these are ESP32 C3 Super Minis. And I think like the eventual goal is going to be kind of this. And you spread these all over and you capture data from them. Like I think the ESP is perfectly suited for that. The other idea is I could run a Raspberry Pi Pico because I have these Pico Ws. And instead of showing on a display, it could show in a web page. The sensor, yeah, the sensor is too big for the ESP, correct. So I could have this and display it on a web page on my network, and then it can show all the data for all of the sensors on the network, because we know we could probably make that work. But the thing is, this is huge. And the eventual goal, I think the ESP is very well suited for, the ESP is very well suited for temperature gathering because they are tiny. So this is a Pico 1. Did I get a Pico 2W? Yes, I have a Pico 2W as well. Yeah, I can, yeah. That's the thing, but the ESP, I don't think I can run 4 ESPs, or I don't think I can run 4 sensors on the ESP, but I can run it on the Pico, that's for sure. Although I don't know if the W adds too much complexity. Also, how shit is this? You make a freaking Pico 2, and then you still have a micro USB. Pretty shit. So there's that. These don't have the W. I could. Now I'm thinking. Oh. Oh, what an. Man, that wasn't a very smart thing to do. You know, yesterday I was looking for my fancy big OLEDs. And I couldn't find them, or not yesterday, last stream. Here they are. They were in my display box, obviously. Well, that was silly. I don't know what the resolution is. It should be big enough, as long as the resolution is high enough. Because this guy wasn't too small, the resolution was too low. Too low. And I can run this on I2C. I can move this 0 ohm over to the I2C. So you see up here, there's a 0 ohm resistor that you can move it to I squared C. R9, R10, R11, R12. That's R9. There's R10. It's probably underneath there somewhere. So we could display it all on here as long as the resolution's high enough. The resolution is oh. And here's all the OLEDs I have. I have actually 4. Okay. So I have 4 OLEDs. Let's see if they're all the same. First and foremost, ground, VDD, SCK, SDA, ground, VDD, SCK, SDA, ground, VDD, SCK, SDA, and ground, VDD, SCK. Okay, so they're all the same. So here's 4 OLEDs. Yeah, I know. Freaking battery cover. I will destroy it with my tremendous might. And by that I mean a screwdriver. Okay, it's because I have no 9-volt battery in there. I don't know if you can see in there, probably not. Oh, maybe I could just power by USB. Yeah. Huge SB. Yeah, I don't know. The resolution is not great. It's big, but I don't know if the resolution is high enough. Still works though. Okay. So I think these OLEDs will work perfectly. I've got 4 of them. I only need 3 because I have a 4th one over there. Actually, I'll take all 4 out because at some point today we might receive these things. Next time I go for coffee, I'll check, see if the Stemma QT connectors are in. All right, so 4 OLEDs or 1 big OLED. We'll decide later on. But yeah, that's why I couldn't find them. It's because they were in here. And, oh yeah, do we have enough RP2040 zeros? I believe we do. 1, 2, 3, 4, and I think I've got 10 more coming in the mail. So we have 5 left, plenty. And so we're going to do a shootout video. Here's the plan. So today we're going to do a temperature sensor shootout video. We're going to work on that. Then I'm going to build an environmental chamber. Maybe not today, but at some point. And I've got these guys here. So I've got these techs. So see that? Tech 12706. So I'll be able to cool the chamber and warm the chamber. So that is the plan. And then, so video 1 is to get the sensors working. Video 2 will be to put them all into an environmental chamber together, and we will map the readings from each. maybe not map. Because if I map them, I'd want them on an ESP on a website to pick up all the... We'll see. We'll see. Maybe we won't map them. Maybe we'll put independent temperature verification and see what they all register. We'll maybe like run wires out, have the micros outside. But anyways, the point is, I've been meaning to build an environmental chamber. And so that'll be a good opportunity. Oh, also, if I had 5 of these are awesome. These are hang on, let me see if I can, ESP32 C3s with a built-in OLED. It's too small, but the video can be as big as I want. Oh, I left my camera. What an idiot. I left my camera with the body open. My God. I need some sleep. I have some 256 by 64 available in OLED. What do you mean? Like I have it in my in my display thing? But also I could do all of them on here as well. So the question is, do I do 4 projects? The one I have, this one? Oh, this one or this one? I think this one is low resolution. Doesn't say. I think this is 128 by 64. Is this one 128 by 64 as well, the small one? That I'm not sure of. So yeah, anyways, either way, this would be awesome, but I think it would have to cycle between temperature and humidity. And they do make these with the RP2040. So that's pretty cool. This I can't see. They don't write the resolution on them, sadly. I also have a label maker coming. So what I'm going to do is going to re-up on my coffee. Hit the washroom real quick. I've been up since 6 doing some coding this morning, so if you want to check the socials for that. Anyways, I'll get some coffee. I'll check to see if we had a package overnight, to see if we got the Stemma QT things, and I'll be right back. So be right back. And I'm back. All right, what did I miss? Stemma QT. Oh, okay. It's the same resolution for the small ones. Yeah, okay. Stemma QT is the same connector as and pin compatible with Qwiic, but supporting both 3.35 volts. Stemma QT is created by Adafruit, Qwiic by SparkFun. Yep. Yeah, connector is just a Pico. Yeah, JST-SH. So this is all correct. It's just that I don't have. I didn't get the. Today I should get the delivery, but I did not get it yet. Not sure what's that in freedom units. Yep. YouTube is funny. Chat working, but video keeps freezing. Oh, that's interesting. Just a JST. Coffee or something else? Coffee. It is. So why it's so frothy is because I don't have a kettle. So it's been a couple of years now that I've been making coffee in the microwave. So yeah, when you heat things in the microwave, the water becomes this like insta boils when you put the coffee in. And then, so this is just regular instant coffee, Nescafe. And I have maple creamer in it also. Okay. So I was thinking of something. If I make a whole bunch of individual projects, okay, with this guy, an OLED, and a temperature sensor, so kind of like these three together, then it's going to be easier to display, right? However, encode, easier to display encode, so everything is simpler. However, that also means I'll need 4 power sources on my bench, so I'll have to daisy chain them around or something. So it could just get a little bit more awkward. The other thing we can do is we can make little harnesses, little wire harnesses for these, and just stack these one beside each other. Maple creamer? Yes, it is. It is definitely. Do you guys want to see what it is? Here, I'll go get it. I'm delaying the inevitable anyways. Up the stairs I go. It's hard to get coffee products that are not made in the States, but this is not made in the States. Ta-da! Oh, that's the French side. Maple latte creamer prepared in Canada. Ooh, lactose free. I didn't know that. I didn't even know that. So these cookies, by the way, these are really good cookies. A couple of companies make them. I think Dare is the company I know the most. But yeah, delicious. I didn't know there was a standard either. Oh yeah, okay, you're driving in the middle of nowhere. So these have gone up in price lately. It used to be 2 for $9. Now it's 2 for $10. Stupid Trumpflation. Anyways. Okay, so let's see if we can make a project. So this one had our button on it. We don't need our button anymore. So let's see if we can do this without vibe coding. Oh, I don't know. Whatever's good, Johnny. I was going to do some shopping, and then you said not to worry about it, so I thought you had it figured out. If you want to be kind, let me just open my ID here. If you want to be kind, some Marabou would be awesome. Audio? Is the audio not working? One board, 4 sensors, 2 displays. Don't know. I don't know if I could do 2 displays because they're I2C. And they have the same address. Okay, so let's go PiPico. I think we're good, right? Are we good? I get some people saying the audio is working. All right. So let's get the example for the SSD 1306. I think it's 128 by 32. No, by 64. All right, so do I need SPI? I'm not using SPI. Okay, audio is good. So I'm gonna try not to vibe code this as much as possible. I have been learning coding slowly, HTML more like, but do I need the graphics? I don't know. Include native fruit. SSD 1306.h. You're back to the interview with Chris. Oh, you were listening to the podcast. Okay, I test things. You're saying 2 pin per display. The fact that it's same address not important. You need 4 pins. Yeah, because you do 2 wire. However, one of my sensors is I2C. So like it gets a little complicated. I mean, I don't think you're wrong, to be fair. Define. How come that doesn't DEFINE? Yeah. Hashtag define. Actually, you know what? I'll just do this. Copy this bad boy. For I2C comms communications library OLED. I wish I could just bit bang this stuff. Hey. This code is written as an example by bin from a simple electronics YouTube channel. youtube.com/simple electronics. Be aware that he is a coder. He is not a coder by trade, but plays one on TV. Did his best to clearly label and comment everything, but AI might be needed. Oops. For further explanation. There we go. Should be good. All right. One sensor, one display, same line, two different addresses. If you really don't. Yeah, I get it. The thing is, I'm going to try to code this, so I need it to be a little bit simpler. Reset. This code is lifted directly from examples included with their libraries. There we go. I don't know what the address is. We'll have to check the address on the I2C scanner. Possibility to make. Yeah, I'm trying to simplify at the moment. So I'm gonna try this, and we'll see how far we get. What the snowflakes? Oh, don't need that. Don't need that either. Don't need this. Don't really need serial. I don't know what this means. If I don't know what it means, it can't be in my code. Display. Okay, so I think the problem here is this is showing the Adafruit stuff, which I don't want. Yeah. you have issues. So I don't know if this is needed. So this is where the vibe coding comes in. To get a bare bones implementation of an OLED, I am using Adafruit's SSD 1306 library's example code to get started. I want to exclude all the stuff I don't need, but I don't know what this is doing. Do I need it? Oops. Every time. No, stop. 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 I don't want this. Stop. Let me new chat. Hold on, I don't know what's on my there we go. Actually important, but only first line does something. But it okay, display.begin. Okay, I need this. Checks whether initialization succeeded. I don't care about that. Yeah, so just this. Just need this in the setup. Yes, I didn't know if I needed, because look, it's wrapped in this if. So if not display begin whatever. But the thing is, this should be somewhere else. Anyways, it doesn't matter. I needed this. This line will start the OLED working. You need this. Okay, that's good. Minimum you need is this. Okay, we're good. Audio all good. Oh, that's good. Okay, so back to the example. This one. So I don't need this. So this is not in the setup, right? It is in the setup. Why does this? Okay, that's all in the setup. Must call the display after drawing commands, make them visible. Yeah, don't need this shit. Okay. So the loop, it's doing nothing. Okay, so right now it's doing nothing. So how do we write to the display? Oh my God. Adafruit, I love you, but you suck. I just let me do something. I think these examples are vain. This is vanity. This is not this is not helpful to people who are learning. Really, really isn't. Okay. So say I want to display test on the screen. What goes into the loop? That's not what I asked. Okay. Okay, so this is not a setup, okay. Where was this? Oh, it was here. Okay. Okay, I need this. Good. Good. All our data from above and apply it to the Adafruit library. Oh, neat. International Chamber of Commerce, huh, in Sweden. All right, have fun with your stuff. Okay. So that's good. And this, now I just need to display dot clear display clearing all the stuff on the screen. Oops. Display dot set text size 1. I make software that stops Swedish companies from exporting anything if the system is down. Huh. Hopefully you get paid big bucks for that. I'm hoping I'll get paid big bucks one day. Normal 1:1 pixel scale. I don't think I need to set text color. I'm gonna write it display dot set text color SSD 1306 underscore white. text. I'm gonna actually comment this out. 150 bucks an hour. So my labor is worth that much, but I don't get paid that much. That's what they charge for my labor. Display dot set cursor. So 0, 0. It must be X, Y. Let's go 10, 10. 10 pixels. Actually, I want to confirm. So I'm going to go 10 and 20 pixels. X, Y, start text. Display dot print line F. I don't know what the F is for. I used to know. Test. No, Adafruit is not. I mean, I think they position themselves as a beginner friendly, but I disagree. It's either that, like, or with peace and love. Either they're not good or I'm the one who's like below their standard, which is fine. Right. Word test into the buffer, and then display dot display like to the screen. Adafruit has switched over to CircuitPython. Yeah, that's another thing. They made a second standard. So it's frustrating. They have a second standard instead of their standard. Because MicroPython should be the standard in my mind. Oh, maybe I do have 128 by 64. Uh, 3C. 128 by 64. Three C. Use I squared C scanner your display address 0x2 3C was mine. All right, so does this compile? Wire.h. Is it capital W? Yes. Yeah, it's possible. So we'll see if this mostly non-vibe coded code works. Seems to be compiling. It's taking forever though. All right, done compiling. Oh, damn it, I just lubricated my chair and it's freaking squeaking again. Bastard. All right, let's see if I can find my USB Type-C cable that I yeeted somewhere around here. Yep, here it is. Put this into boot mode. See if we get a test on the screen. Upload. Yeah, Turtle compiler. Done uploading. So now, in principle, should have a working display. Yeah, hate to say this, but where am I? Oops, it's my programming cable. We got nothing on the display. Pins 4 and 5 are the default I2C. I remember that. Does the display need 5 volts? Reset. They share a ground. That's good. Okay, something isn't working. So let's see if I can set the I2C to 4 and 5. It should be the default, but it's not working. In fact, it needs to recompile when it just compiled. Yeah, I know. Look, I'm worried with the tools I got. So ground, VDD, serial clock, and serial data. Okay, well, let's go see if we can modify this. And I'm pretty sure it's address 3C. So I'm going to ask the question. Why did I not have to use wire.h and set my pins for I2C comms in this example? I am using RP2040 chip. Oh. When you construct and wire. Okay. SDA is 4 and 5. Wait, but it doesn't just work. Okay, hang on. Let's remove this. Oh wait, maybe this is why it doesn't work. Maybe you do need this. Okay, hang on. Try to put it into boot mode. Let's see. No, Platformio sucks. If there's a better option, you let me know. But this IDE makes me want to, you know, push 9-inch nails into each one of my eyelids, and it's still better than Platformio. Platformio sucks. Okay, let's take a look here. If there's a better option that does use VS Code, that doesn't use Platformio, let me know. I'm all ears. I'm not using Platformio. Not at all. Okay, so that works. It does look like... So our larger number was definitely Y. So I'll have to confirm that. So that works. So I did need the text color, which is silly because this could be any screen. So our large number was Y. Yeah, okay, that's good. Great. So take this like so, and then here is a block of code you can use to display anything you want. We will definitely display dot clear display clear anything on the screen since last reboot, and display dot display that empty buffer. You know what? Maybe I'll put my own vanity text in here. So we'll do that after. All right, so now we need the DHT11 code. So let's go examples. If you know how to code in C, you better avoid the Arduino IDE. Well, eventually I'll learn C. I mean, it's the language I'm the most comfortable with, sadly. Don't I have a DHT sensor library? So what is this? So why unified? See, this doesn't say why unified. Okay, these are all together. So you need all of these. What the hell? Don't need any of this, right? Hang on. Examples. Just DHT. Okay, there's a DHT straight up library. Okay. OLED stuff. End of OLED stuff. I want to just make it clear that people can modify the code easily. Start of DHT sensor stuff. All right, so we need to include dht.h. DHT sensor library needed to interface with it. Arduino is supposed to be simpler than C. I think it is slightly simpler. This is good. This is good info. This is ripped straight from the DHT library. That's good. this. Take this. Okay. Like so. All right. So that's good. I like this. This is very, I need to do this more. The connections. Oh wait, we need the DHT pin. Connect this pin to the data pin of your DHT. Pin 2. Don't care about the serial. Okay, so this should work. Don't know why a float. The float, why it used in this DHT library instead of, say, integer. Your test all passed. Congrats. Espressif have an IDE? Yeah, they do. Floating point number. Oh, decimals. Okay. Okay, I understand. Okay. This is, by the way, this is the proper use of AI, is to learn things. All right, so that's good. We're all right. So let's grab this. HT, all right. Float H equals DHT dot read humidity float Yeah, that's pretty funny. Float T equals DHT dot read temperature, and then float don't need to read Fahrenheit, doesn't matter. Error checking. Remove this part if you don't want it. index. But do we have to move is Fahrenheit to false? This is the default. Oh, you send true. Okay, don't need that. Heat index. Interesting. Wait, why do I need an extra flag? Why would it do that? Fahrenheit is obviously the garbage way. Anyways, whatever. Let's see if that works. I don't ever want it to read in Fahrenheit. Fahrenheit is garbage. No offense, Americans in here. And, stuff. Okay. Oh wait, HIC. Float HIC. Okay, so now I want to clear display. Displaying our sensor. So this stuff is what I need. Clear display, text size 1, in white. Start at, I don't know. We're gonna have to tune this after. It's user in the system only setup will run debugger. Oh. 10.0, print f, tht 11, right? We have 11. Oh, 22. THT 22 readings. Okay, oops. Do we know how big the fonts are? Set cursor. I don't know how tall the fonts are. 10. Display dot print Okay, we're going to go T. You need to test to know. Yeah, okay, I thought so. So T. But let's start with this. Let's see what we got here. Let's see if it compiles first. Need to go to the washroom again, but let's do this test first. F was not declared in this scope. No. So I don't need it. Yeah, I don't need it. You know what? I will just see if this uploads. There you go. F was not declared. Why would it be? No, it's C. Wait, it's T. Let's try that again. Expected at the end of input. Oh, missing this here. I'm not making freecodecamp.org look very good, huh, by screwing up basic coding. By the way, go onto my socials, especially my Blue Sky, and like my post. Oh shit, maybe I should put a delay here. Hang on. I don't want this to happen all the time. Delay 1000. Upload this instead. Do I have to unplug? Uploading error. Where's my package? Waiting for my freaking AliExpress package with the stuff. So a clear display, text size 1, white, set the cursor, print F this, 1010. This is the T. It should just grab that from the DHT. And now we just need to connect the DHT in this manner. Leftmost pin 3.3, and then pin 2 to pin 2, pin 4 to ground. Oh, I want to arrive before tomorrow. Is this the 22 or the 11? Of course this is the 11. I want to arrive today. Although today I should do editing, but I hate editing, so I don't do a lot of it. All right, like so. That's in there. Oh, you know what? I'm gonna free ball it. So this should go to pin 2. 0, 1, 2. Actually remembered to start at 0. Power. Is 3.3. Like so. And then ground is in the ground here. All right. Place your bets. Do you think it'll work? Is this not plugged in? McFly? Okay, that turns on, but it's gibberish. When I plug this into the 3.3 volt, it goes nuts. Okay, something is wrong because this shouldn't display static. Because no matter what, this should display something. It is pin 2. Because, yeah, no matter what, this should display. And it's not displaying. Just shows gibberish. But it was working. I had a test on it before. So what's changed? So let's remove this. Display.clear display, text size 1, text color, then set the cursor. Is this a big F up here? Yeah, F bracket test, F bracket this. That should directly print my variable. Might have to send this to AI to see why it's not working. Boop. There we go. Let's upload this. Like it should do something. Webcam. Do I plug it in or do I not? Let's not. Okay, so let's see. Oh, it works. So that stupid bit of code didn't work. Okay, so now I'm gonna plug this in. Two. Okay, so let's see if we get our first readings from the DHT. We're not getting anything from the DHT. So it's not our T value. Oh, it got something for a moment there. Something is a bit finicky. It had a 12 point something. Let's reset. Oh. So it worked, and then it stopped. Did you see that? Reset. 25.2. Back to nan. So it works for one loop. It stopped working. Just going to check the voltage. Make sure we're not drawing down our 3.3 volt. Let's see. Nope. 3.3. So what is the issue? 3.3 in ground. We should be getting readings, but our T is not being updated. Okay, also we need to add space to the DHT22 readings. Right, this is a 22. Let me try a different DHT22 just to make sure it's not that sensor that is pooched. These have been sitting around in my workspace for a long time. Okay, reset. Nope. Okay, we need to add spaces to the, oh, it worked for a minute there. Welcome back, Franco. So it works for one iteration sometimes. Okay, I need to go to the washroom. And as much as I'd like to have another coffee, it's probably not healthy for me. So I'll just be right back. We're working our way through. We're not vibe coding as much as we could be, and that is making it take longer. But that's okay. I'm learning. I'll be right back. Okay, I'm back. You're just in time for a break, yeah. So somehow it iterates once and doesn't work after. So let's see. Now we don't know if it's displaying properly. Well, let's take a look at the screen here. So, T, so in the loop, so they're doing this. So they're putting a delay before. Maybe that is the key. Let's put a delay before. Because maybe it needs to be like online. And then, you know, take a moment and read. We're gonna shove the cursor over, maybe 30. So this should just display my T, which is good. So let me put this in the boot. And let's upload this. So now this is the same. Actually, you know what? I'm gonna ignore this for now. So this is the same as this, except I don't have the isnan garbage. That's gone. Didn't need that. Come on. Done. Okay, so I'm always tempted to hit the stop recording. We are going to connect this way. $24 and then nan. Problem is I don't know if the problem is the T is not getting updated, or if my screen isn't getting updated. Also, DHT is almost center. We're going to move it that way a little bit. So that doesn't work. Ugh. I might have to use serial debugging. I don't want to use serial debugging. Serial debugging sucks. All right. Let's get this all gone. It's a very slow sensor. Reading temperature or humidity takes about 250 milliseconds. Really? Really? Is it that bad? And we just want the we need to do a serial begin. Begin speed RP 2040. None of this is answering my question. How do I open the serial monitor? Okay, let's remove the serial. I don't even know how to have the serial monitor open. Okay, it did fail. It's failing to read. My idea why code should work. I'm thinking okay, needs to be pulled up. Adafruit DHT library. Oh, my multimeter's freaking out. It says try it from the 5-volt bus. Okay, doing that now. It's on the 5-volt. It's still failing to read. I'll hit a reset. Reset. Still failing. Oh wait, I got 24. I have 24.7. It's reading now. Is it failing now? Yeah, it's not. So now it's not updating. Resetting again. It's in my hand, so it should be. It's definitely not updated. What are you guys doing? I'm not clicking that link. Resetting again. Okay. So I am using the Adafruit DHT library, right? Yeah, written by Lady Ada. Okay. Maybe I need a pull-up. Okay, hang on. Does the Adafruit DHT library make my RP2040 pin pull up by default? Does not. Okay. 10K to VCC. Okay, let me see if we have a pull-up by default. Because this is a board. It has a cap on it. Oh, and it has a resistor. So we just need to know if that resistor is between output and power. Yep, there's a 3.3K pull up. Let me just disconnect this just to make sure. Yep, 3.3K pull up. So it's right there. And it has a capacitor. I don't know what else to do. Pull up internally inside doesn't hurt to add another one. Well, so it has a pull up. This is like a multi-purpose sensor board. Okay. So this PiPico, it's not able to read the DHT. I mean, the code could not be any simpler. I mean, an idiot wrote it. Screen. So this is just the Adafruit stuff. So here's the DHT stuff. So include dht.h. That is my sensor library, which I got from the example code. Then the type 22, which is here 22, DHT pin 2, DHT pin 2, and the pin assignments, which are correct, and then DHT pin and type, and that's it. This is the SSD stuff. Here's the loop. So on the official Adafruit, it says wait 2 seconds. So I wait 2 seconds, and then float T, read temperature in Celsius. Float T, read temperature in Celsius. Then there's this check to see if you failed to read, which I put in here, but I can delete this now anyways. So that's failed to read, and then here's just more shit to compute, and then here it just says print the T, but I do it on the display, print the T, and that's it. And then it gets to the end here, waits 2 seconds, and then reads the temperature, which is this. That's it. Check the cables. The cables is fine because it does work sometimes. It seems like the RP2040 is too finicky. It doesn't work. I think the Pico is too fast. No. It doesn't work intermittently. It works most of the times on a reset for like one go, and then that's it. It stops. It works on either, Franco, but I've tried it on both. So I think we're just boned. Because if we can't just like read the temperature, it works sometimes on reset, yes. Something needs change to DHT read temperature true. It shouldn't matter. I'll try, but it shouldn't matter. Let me just reconnect. Put this in boot mode. My freaking voice is crackling again. Maybe I need a crappier processor. Oh yeah, wait, I'm not doing any serial anymore. So, nope, still not working. Reset. Okay, it worked once, back to not working. Reset. Worked once, back to not working. Resetting. So it's showing me 77 degrees. And then back to not working. So that's the true forces an actual read. Are you sure that the true doesn't just give you a Fahrenheit read? Because it is giving me a Fahrenheit read. Do I have to declare this as a pi pico? Because yeah, now it's, when it does work, it's giving me a temperature in like Fahrenheit. It's giving me like 70. Start of the loop. Uncomment DHT. I'm not going to, no. I'm not going into the library. I'm not going to use the library if the library is at fault. Essentially. Because I want this to go to other people, so they need to use it as is. This is the one I have. Library. DHT. I'm using 22 right now. Yeah, 1.4.6. But I don't have a serial going or anything. And I don't know why they want the unified sensor when we're not calling it anywhere. You know what I'll do? I'll just run this. Hang on a sec. This is literally the Adafruit test. So that's working. I'm just covering it with my hand now. Did I ever tell you that I hate coding? Because that means the problem is in my OLED implementation. If I use I2C, it doesn't work. Sometimes I wonder why I even bother. Because now it looks like, I don't know if you guys can, this is a shitty ID, so I can't show you this any bigger. But this example works perfectly. But then you add an OLED, it doesn't work. So the screen is the problem. So what the hell do I do? I guess I just give up. But the screen is also Adafruit. Oh. This is so discouraging. I think it's just time to go to bed. It's incredibly discouraging. They do not. No. Fuck that. I'm not going asking for support. DHT22 temp sensor to display degrees Celsius and humidity to SS something. SSD 1306. 1306 OLED. Use I2C using RP2040 0 board. I can get the OLED working. I can get the DHT22 working, but can't get them working together. Can you? Yes, I'm not. The issue with asking for help is that they make assumptions, and I don't understand pins 5. Hold on a sec. 4 and 5 are SDA and SCK. 4 and 5 are SDA SCK, and the DHT is on pin 2. So ChatGPT is not, it doesn't make assumptions. Or, well, it gives me all the code and doesn't make me, like, ask me questions I don't know the answer to. You know what I mean? Okay, so I really tried to code this from scratch and it didn't work. So let's see if this will work. And I don't know why it added the graphics. I don't even know what the graphics are for. There's no way that ChatGPT could replace Vero. Ugh. It's not even close to smart enough to replace Vero. So let's see. And it works. Let's see if it really does work. Trying to. Oh yeah, it works. So why is it that it can be vibe coded, but not manually coded? Okay. That is frustrating. What's the difference here? Let's go over this, shall we? So one of the big difference is they included wire, which technically you don't need because wire is here. Oh shit, sorry. And why do they add this? Why is Fix library. Oh. So you need it. Okay. Okay, this is all 128.64. Adafruit screen address. Then Adafruit display, screen width, screen height, wire, and OLED reset. Okay, then we got a serial begin with a high baud rate. That doesn't really matter. I skipped all that. Initialize DHT. Oh, this one has a begin. Do I have a begin? There's no begin. Do I have to begin the DHT? Hang on. Nobody say anything. I don't want to hear it. I don't want to hear it. I don't want to hear it. Don't say it. Do not say it. I don't want to hear it. Don't say it. Don't say it. I don't want to hear it. Chat. Don't you dare. Oh, shit. Don't you dare, chat. Don't say it. Let's see if it works. It's a slow ass sensor. 25. Heating it up with my hand here. 26. Okay. Let's continue development as if nothing happened. How about that? How about we just ignore that all of this happened? Okay, don't need this shit. Get out of here. Get out of my face. Okay. Okay. Let's ignore all of that. Okay. How's it going, Gerald? Exactly. Exactly, Gerald. There was no nothing. Okay, so anyways, 0, 10. What's the difference between print and println? Isn't println like a line? Print versus println, or do we know? Without moving the cursor. So I think I could just use print. Anyways, display dot print f temp, and we need to move the cursor over, I don't know, like 20. Display dot. I can't see my. This thing is upsetting. Anyways, set cursor maybe 30, 10. Print T, and we'll go display dot set cursor. Let's go like 50, 60, 10. We're setting up the template here, so it's going to take a little bit. Display dot print tester. I'm going in here because I want to steal this. Degrees Celsius. Okay, let's see what that looks like, and we'll move things around. All right, boot. Upload. See what it looks like. Okay, so it's not able to display the degrees. The temp is correct. I'm going to move it down a bit. Let's go 15. It's not able to do the degrees, and that's probably because we don't have the Arduino GFX library installed, which this one doesn't either. Okay. So how does this one not have the GFX library, but it can display it? Anyways, we'll try this. GFX. And I need to move this over. I'll go 70. Let's upload this. There are definitely people who fall for ChatGPT. People got really upset when GPT-4 was updated to 5 because it was much less of that personality. Okay, we're going to move this a bit over. 22. So maybe we'll do the star C. Is that better? I'm going to show you what it looks like now. I'm just tuning a little bit, and then we'll get the humidity written. Add a space here and move this one like 60. See, I can't get the degree symbol to show up. That's okay. Upload. Okay, this one I'll show you guys once it uploads. So that, so this here, what GPT did for this here. So, okay, so I just want you to understand. So you said it's crap, right? So here, because you need the default font, use ASCII only. Okay, so here, this is Adafruit. This was written by Lady Ada. Okay. Wait, it was in there. Oh, the GFX one. Alt temp? No. This one. Here. So there it is. Written by Limor and Lady Ada. So here's the exact place where GPT got it. Yeah, so
I guess what you're what you're saying is that Limor and Lady Ada wrote crap code. Okay, so here's what it looks like so far.
If they ever come onto the podcast, I'll tell them you said that, because I'm in no place to judge. There we go. So that's what it looks like. So temp, and then I'll add the humidity. Then we do the same thing, but a bunch of pixels down for humidity. I'm probably gonna get the text size bigger, but I don't know if then it'll all fit. You know, the importance. Okay, gotcha. Actually, that's one thing that Free Code Camp is really good at. It's teaching me to write maintainable code, which is great. Okay, so display dot set cursor. That's my offset. So 15 will go 30, 0, 30, and display dot print f. We want humidity. So that's gonna, let's see, how many characters? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Almost double, but not quite double. Set cursor. So 30 will go 55, 30. Display dot print h. Display dot set cursor. 60 plus. So I left 30, so 55, 85, 30, display dot print f. Percent. You maintain code that is sometimes over 20 years old. Interesting. Okay, so let's get this. Oh wait, we gotta actually get the, there, yeah, read temperature, read humidity. System crafts will be streaming soon. Terminal tools for Text Titans. Well, you're welcome to go see his stream. Like, don't feel the need to stay here. I do appreciate you being here, but you don't have to be here. See if I got this right on the first try. Oh. Oh. That's semicolon. Upload. Morning, Mr. Ireland. Go uploading. Done uploading. I think I nailed it. Let me show you guys. Let me switch the screen first. USB cable. There we go. It is functioning. So that's good. It is all working. So now, all that would be left is to do the same thing for DHT 11 and then work on the two other. So we've got the, so this guy, I'll have to make a little board because I don't have, oh, I may have a version of this. Give me a second. Let me see. Don't I have a sensor kit? This guy. So that's DHT 22. Is this still working? Yeah. Here is a DHT 11. Right? Can't read. Yep. Here's a DHT 11. So here's a standalone, but I've got this one. So that's good. Now the question is, do I have one of the little Philips ones? Oh yeah, I love these OLEDs as well. Oh, here it is. Here's a Dallas version as well. So I have essentially all of them aside from the BMP sensor. Let me see if there's a BMP sensor. I've got the sheet here. There's the 18B20. There's the DHT. No. No. So yeah, I'll have to, so if I get this working for DHT22, redo the code to work with DHT11. And that's pretty much it. I think I should probably double the size of the text though. before I use this as my template, I should double the size of the text so it shows up better on camera. Oh, big stretch. Blue one with a yellow strip at the top, using it for displaying BMP 280. Oh, there. So yeah, the BMP 280 is on the list too. So I essentially want to get all of this working, and then yeah, make a video with all of them, and put out my code so people can make them. So here I've got all the RP 2040 zeros, and I can honestly make a PCB for each of them, but I think that's not necessary. So I can make a PCB for all of them anyways. And there's the OLEDs. Okay, so DHT22 is working. DHT11 is next. And I guess now the cool thing would be to add an SD card. I do have SD modules, I think, but maybe not small ones. Hold on, let me see. What do we have for SD card modules? Because it'd be nice to be able to data log. Screen. SD module. That's cheap. Is that a welcome deal? That's got to be a welcome deal, right? Because that is cheap. Let me check. Nope, it's literally $3.80 for 10 of them. Add to cart. Prototype PCB to run a BMP with an OLED off the ESP32C3. The ESP is having trouble connecting to Wi-Fi. Yes. So, yeah, but shipping is it's choice, which means that if you buy over $10, shipping is free, and it's relatively fast. Yeah, so the ESP32C3 is single core, isn't it? ESP32C3. So yeah, I think it's single core. And so the problem with the single core ESP32s is that the dual cores use the second core for Wi-Fi. And so if you're using a single core one and you're doing stuff that's computationally intense, it interferes with the Wi-Fi. That's why you want choice is your only choice. Yeah, me too, Gerald, I agree. I almost always go for choice. It says so on the first line. Oh, single core, yeah, right there. So I think your best bet, ESP32 0. So the C3, I think it's the S3 in 0 format. So that is like your smallest, most capable ESP. Yeah, but it's expensive. I've got them. They're not that expensive. Let me see. Check my orders on the other screen. For 5 ESP32 S3 zeros, I paid $28.75. Give me a second here. Oh, it went up $29 and something. So like 30 bucks for 5. Whatever that is. $6 a pop. They're super powerful though. The S3 is a dual core. Wow, this looks a lot like Xeon's page. Is this Xeon's? The style is very Xeon-like. Oh, it is. I was like, what the hell? I was like, this looks like Xeon stuff. But it is Xeon stuff. He bought ESP32S3.com. Funny. Wow, he's ranked high, actually. Because 1, 2, 3, fourth from the top. Anyways, let's look at this S3. Let's see. So yeah, dual core. Main frequency 240 megahertz. Wi-Fi 512 kilobytes SRAM. So yeah, I want this. Your first ESP32 was a Tiny Pico. Xeon sent me a Tiny Pico. I haven't used it yet. So I think one of the challenges of this is that you want to build your board. Give me a second. My start menu is all screwed. I don't know if I could just draw you something on here. Curves, and can you just get a pen? Is this a vector drawing thing? Oops, whatever. No, leave me alone. Okay, so you've got your okay, so that's your ESP. Your ESP0. And here's your USB.
So if you want to power, oh, and here's your antenna. So if you want to power your device via USB, you want the USB to be at the edge of the board. Can I get another layer? Yes, I can. Let's grab this guy. This guy. Can I just move it? Yeah. Excuse me. Whatever. So, yes. Anyways, you want to put your USB cable on the top there, which means that you want your PCB on here. So you want your PCB, I'll take another color, red. You want your PCB to be like this. Sort of like that. But then the issue is, God damn it. Then the issue is that this antenna is now obfuscated. So you need to kinda make your PCB like this. So kind of like this, you know, so then your components are like here, and then your antenna is free from any obstructions. However, that then means your PCB is like a weird form factor. Bit strange. All right, don't save. Okay, so let's go text size 2. Whoa, not 23. And let's see what happens when we upload the code. Upload the code. Yeah, so then you have to add external parts if you want your USB connector on the main PCB. So I'd have to order USB Type-C connectors and then solder them on, which is I think is okay for me. I think I could deal with that, but it doesn't make it friendly to other people who want to do your project. All right, so let's see what kind of mess this gives us. I think I drank too much coffee. I need to go to the washroom again. Okay. I will show you what this looks like, but we need to do some modifications here. So this is what this looks like with double-sized text, which I think double-sized text is the way to go. My God, I need a better USB solution here. So it's all stacked on top of each other, but I do like the size. So I think I'm going to go DHT22 on the top, and then T for temperature and H for humidity. So I think that's the plan. Okay. Yeah, it's not that strange of a shape, but it does make it like not very compact. Okay, so we're going to start at like, let's say 20, and we'll just call it DHT22, and then 0 will go, that looked okay actually. Well, let's go 20, so that's X and Y, go T, okay, that's 20, that's 20, this doesn't need to be 60 anymore, 30 degrees C, and then this will go 40, 40, and 40, and then H. Now this will be the same distance, we'll go 30, oh, this needs to go, let's go 60, 60%. Okay, and we're gonna send that. I'm gonna see what it looks like. If it looks funny, I'll bring you in. All right, upload. I do like the bigger text. It'll show up better on screen. Okay, I need to move this way over. This one. Let's go 90, 90. Let's try that again. Upload. Oh, that was perfect. All right, let me just put the DHT a little bit more centered, and then I'll show you guys that this looks pretty much the way we want it to. Upload. Now another couple pixels. 33. Trying to get this correct because I'm just going to repeat this exact same code for the DHT11. Okay, I think we're good. Let's go over to the webcam. I'll show you what it looks like. I think it looks good. I think it looks very good. There we go. What do you guys think of that? See if I can modify the lighting so it doesn't pulse so much for you guys. Ugh. Oh, there we go. And if I cover this, humidity goes up much quicker than the temperature. That looks good. It's definitely heating up. I can add more humidity too by breathing into it. I think that looks really good. So I honestly think a PCB for this would be neat, because the DHT 11 and 22 can have the same PCB. I can also add the I2C for it to do the BMP sensor, and then the one wire sensor can also go into the same port. So I think this is our next PCBWay PCB. And I don't need to order any parts. So this is freaking awesome. So yeah, it says 26. It needs a little bit to get back into the swing of things, to cool down. If just this thing was an ESP, this could already be sending stuff to the cloud. And by the cloud, I mean my computer. Okay, before we modify this and test it with a DHT 11, I'm going to have to go to the washroom. So I will be right back. Oh, you guys can't see that. It's be right back for coffee, but not in the same way. It's exiting coffee, not entering coffee. Be right back. And I'm back. So
this is a great project. I think I'm going to do this. The only thing I'm now thinking is, I guess I'll make a video with the Pi, and then I'll make a larger video using the ESP. And another thing I'm thinking of is maybe those ESPs, they can report back to another ESP. I'll definitely need to vibe code that, but for now, let's get this working with the DHT11 now. Actually, I'm curious, what happens? Hold on a sec. Now I can't see shit. What happens if I just plug in the DHT11 on? I don't think. So this is, the pinout is a little bit different on this. What's wrong with the font? The font works just fine. I'm curious. So that doesn't work. Okay, good to know. What do you mean looks like crap? It looks fine. It works. It's functional. My code will be open source, so you'll be able to do it yourself. Okay, so let's do this. So I'm gonna actually send you over there. Save as. New folder, temperature stuff, and then new folder, DHT22 example. Okay, back to screen. Mono looks like a coding font. Okay, so DHT 11. Pin 2. .11, which is why we like it. I'm not a coding guy yet. Just you wait though. I'm working on it. I'm almost done the HTML curriculum, and then I'll be moving on to CSS. All right, let's see if this works first try. Come on, compiling. Helvetica, okay. I got so used to Calibri because it's the default Microsoft Word font when I was in university.
Okay, so let's see if the DHT11 works. If so, we're going to save it and call it a day. I'm going to modify the code a little bit to be more readable. DHT11. It's working. Does it respond faster? I think the DHT11 is slower. Works. Okay. So now the more complicated one. So DHT 22 is done. 11 is done. Now comes the more complicated part. This Philips sensor, slower and less accurate. Thank you, Curtis. So this Philips sensor, no humidity, just will give us temperature. I keep forgetting the name of this damn thing. This is the 18S20, 18B20. So this, and then last and not least is this BMP. Yeah, GY BM280. Bookmen for serif fonts. I know some of those words. Okay, let's solder this onto a pin header. By the way, this is not going to be done today. I'm probably going to be calling it quits fairly soon. Maybe even before we try the BMP. I don't know. But the next stream should be tomorrow. Can someone in the chat, who knows, tell me if the ESP32S3, if it can use any pin for its I2C, just like the Pi or the RP2040. Please and thank you. Because my sneaky plan is to use the RP2040 for my video and then replace it on the same PCB. Just have to override the settings in the code. Okay. Because I'm thinking I will make a PCB. This is my genius plan. I make a PCB for the RP2040, use it in that video, and then reuse that PCB in another video for the ESP32 and make that my bigger project where I'm going to be collecting sensor data all over the house type thing. Also, true or false for the coding nerds in here. If I give my ESP access to the internet, do I still need a real-time clock to get date and time data for temperature logging? Or can I just get it from the internet? You need to set an NTP source. What's a NTP source? It helps that we still have time and date before it syncs. Okay, so what you're saying is real-time clock is a good way to go. So then it probably will make new PCBs. I'll probably make new PCBs then, because the thought is that a real-time clock will help for sure. Okay, so clock module. Let's see if we can get small ones. Pool.ntp.org, NTP time source address. Okay, okay. Oh, what? It has a temperature sensor built in, but it's shit. It's pretty shit. Plus minus 3 degrees. But it has a built-in temperature sensor. Interesting. I believe that's the same one. Yeah. Well, here's a whole bunch of them. If there was a real-time clock that had a better temperature sensor built in, Interesting, interesting. Because I would want to poll it maybe every 5 minutes or something, or 10 minutes, and then grab the data. I'd probably have it send data in here. And then I would take a look in here. And then I would probably get another ESP to draw a graph. I know they can communicate by ESP now. And then have it write to the SD card as a backup. Anyways, I think I will, oh yeah, save this file, save as. I'll just save this. DHT 11 example. Yeah, but you don't need temperature data every minute for like weather monitoring. That's what I would be doing, weather. I wonder if I'm wasting my time. There's, yeah, this is expensive, but this has wind speed and everything. I don't care about wind speed. All right, well, I think that is it for me. Tomorrow, the plan is to do the Dallas Semiconductor, like the whatever, and the BMP, the I2C1, and also make a PCB to combine all of them. Yeah, so essentially to make a display PCB. And then, so tomorrow's stream will be that. Sunday we'll probably stream again, but we'll see what we're doing on Sunday. But thank you everyone for being here and for watching. Today I have to do some editing, so hopefully I'll have some videos to post for this weekend. But thanks everyone. Have a good one.